All right, so this 5 just stands for this being fifth period. But flux is a fancy word that means flow. That's all. Now, our magnetic flux, and the symbol for a magnetic flux is an uppercase phi. That's phi. So the flux is bigger if the field, like when I was explaining it as a raindrop, so our field is bigger, the flux is bigger, and if the area is bigger, the flux is bigger. And then what was, if I rotated it, so what was the relationship between flux and the angle? It was a cosine function. So cosine theta. That's your magnetic flux. We can have electric flux, we could have gravitational flux, any kind of field could have flux. Y'all like a box? So let's throw a box around this and we'll define each little bit here. So the magnetic flux, that's this phi, kind of looks like a sideways TIE fighter. And we'll get to the units in just a second. So B stands for the magnetic field. And magnetic field is still measured in Tesla. A stands for what? Area. And what's area measured in? Meters squared, right? It's the area of the surface or the loop or whatever you want to describe the shape as that the field is passing through. All right, now theta is the angle between, so this was a little bit different. This is the angle between the field, in this case the magnetic field, and this is where the tricky business comes in, the normal to the plane of the area. Normal means perpendicular, so the normal line to the plane of the area. So if magnetic field is in Tesla, area is in meters squared, and the cosine of an angle has no unit, then what is a magnetic flux unit? Tesla meter squared. Very good. Tesla meter squared, which is also known as a Weber. WB for Weber. I'll put it in parentheses, Weber. And I would say that about 50% of the time you see Tesla meter squared, and about 50% of the time, which would be the resulting percent, right? You see Weber. So as we change the magnetic flux, and you can change the flux by changing lots of different things, but as we change that magnetic flux over time, we induce an EMF. So this is the induced EMF, or voltage. And you could set that equal to I times R, just like you would any other V equals IR type problem. So this induced EMF, change in flux over change in time. And now we can have a change in flux by changing just about any of those variables, one or more of them, and we've got a change in magnetic flux. So if our magnetic flux is BA cos theta, we can change the magnetic field, strength. We can change the area, so we could have a change in flux by changing the area. We could even change the angle by maybe spinning the loop. But be careful if you change the angle, because it's not cosine of delta theta, but it is it's the change in the cosine theta. So I'm going to write it out, cosine theta minus cosine theta naught. So those are at least one